Hello and welcome to this introductory video on chemical analysis aimed at national level. Okay, so we're going to start by asking why we do chemical tests at all, why we do chemical analysis. We'll be introducing the term qualitative analysis and explaining why it's different from what we call quantitative analysis. We'll be reminding you of some basic chemical tests, introducing flame tests, and chromatography. Okay, so first of all, why do we do chemical tests? Well, there's all sorts of reasons in everyday life. For example, suppose you had a chemical factory, okay, and you suspect that might be leaking chemicals into the environment. You're going to want to be able to test for that, and you're going to want to measure how much chemical is leaking into the environment. On the other hand, you could be a forensic scientist. Okay, you suspect somebody may have been poisoned, shall we suppose, and you've got some trace of their last meal. You want to know what's in there, if it's poisonous, and if so, how much there is. Or you might be a geologist. You might be looking for minerals that we can mine. You might want to test a rock to see what chemicals are in it. All these then are reasons we might do chemical analyses. Now, when we do a chemical analysis, there are two types of question we can answer. In fact, there's basically two broad types of question we can answer. Suppose some careless chemist has left a bottle of chemical there without a label on. Now, I hasten to add, no chemist that I know would ever do that. But let's suppose that's what's happened. What are we going to want to know? Well, we're going to want to know what chemicals are in it. And we might want to know how much of them is there. Okay? So if it's a solution, you might want to know how concentrated it is. Okay, a question of the form, what chemicals are there, that's what's called qualitative analysis. Qualitative is about what chemicals you've actually got. Quantitative analysis is about how much of them you've got. Okay? So one is about qualities, one is about quantities. Okay, and we're going to be dealing here with qualitative analysis, how we find out what chemicals we've got. Now, some of this we've done before. We've got some basic chemical tests. Okay, suppose, for example, you suspect that you've got a gas and it's hydrogen. You suspect you've got hydrogen gas. What you do? You take a burning splint, and what you find is if that gas is hydrogen, it'll burn with a pop. So that then is your test for hydrogen. Burning splint, the gas burns with a pop. What if you think it might be oxygen? Well, it's a test for oxygen. What you want for oxygen is a glowing splint. You set the splint on fire, you blow it out, and while it's still glowing, you put it into the test tube, and if the gas is oxygen, the splint will relight. Okay, so that is your test for oxygen. Glowing splint relights. Finally, you've got carbon dioxide. For carbon dioxide, your test is lime water. You get some lime water, which is colourless. You add it to your test tube. Now you'll want to give that a shake. If the gas in there is carbon dioxide, when you shake it, it will go milky, cloudy. If that happens with lime water, then the gas is carbon dioxide. So those are your three gas tests. Tests for hydrogen, oxygen, and carbon dioxide. We can also test for acids and alkalis. The standard for that is universal indicator. There are other indicators you can use, but universal indicator is common. Universal indicator is green. You add a few drops to your test tubes, shake them. If it goes red, then the liquid is an acid. If it goes blue or purple, then the liquid is an alkali. Okay, so this tests for acids and alkalis. The final test I want to mention is the test for water. Now this is less familiar, but what you want here is cobalt chloride paper. Now when it's dry, and you do have to make sure it's dry first, so you get dry cobalt chloride paper. You put it into the water and it will go pink if the liquid is water. Okay, so that is your test for water. Cobalt chloride paper goes from blue to pink. Okay, now I want to look at flame tests. Flame tests are a way of testing for certain metal ions in compounds. You're looking for certain metals in compounds. So what you do, you get a little glass rod and you make it damp at the end. You stick it into your chemical so you've got a little bit of the compound there on the end of the glass rod. You put the glass rod just at the edge of the blue flame of a Bunsen burner, like that. And what you find is the flame changes colour. Okay? Now the colour will depend on the metal in the compound. Some metals change the colour of a Bunsen flame some very distinct colours, like that. And in your data book, you should find a table that identifies the metal in the compound based on the colour the flame changes. So for example here, if the flame changes lilac, then it means you've got a potassium compound. It doesn't tell you which potassium compound you've got. It could be potassium chloride, potassium nitrate, potassium sulfate, but it does at least tell you you've got a potassium compound. Finally, I want to look at chromatography. This is a way of separating out the substances in a mixture based on their solubility. Now, the standard example of that uses inks. Okay, so let's suppose we get a piece of filter paper like that, or if you're flash, a piece of proper chromatography paper, and you draw a line along the bottom like that. Now suppose you've got an ink, and you think that ink is a mixture of different colours. You put a little spot of it down there. Then you decide what colours you think might be in that ink. And you make a few spots along there of those colours. And you get a beaker with some water in, or some other solvents, depending on what you're actually doing here. But we'll use water here. And what will happen is that the water soaks its way up the filter paper, carrying the inks with it. Now, do you notice the one on the left there we started with, the black ink has separated out into two spots. Okay? Now, how far the spots travel depends on how soluble that colour of ink is. The more soluble the ink is, the further it will travel up the filter paper, because it's more able to stick to the water if it's more soluble. Okay, so notice that dot there from the original ink is at the same height as that dot there, the red one. That suggests that that red colour was the one that was in the original ink. Similarly, that dot there is at the same height as this purple one. And that suggests that that purple dot is the colour that was in the black ink. Okay, so to sum up, qualitative analysis is about identifying substances. We've seen your basic chemical tests, your gas tests, test for hydrogen, test for oxygen, test for carbon dioxide. You've seen pH testing using a universal indicator. And we've seen how we can use cobalt chloride paper to identify water. We've mentioned flame tests, and that can be used to identify some, but not all, metal ions. Incidentally, this flame testing thing, the ability of certain metals to change the colour of the flame, explains why they are used in fireworks. This is what gives fireworks their colours. And finally, we looked at chromatography, which separates the components of a mixture, allowing you to identify them, and that method depends on the fact the different parts of the mixture have different solubilities. Okay, that's all for now. Thanks for watching. Bye for now.